In this lesson, we are going to be discussing arithmetic sequences and to state whether a sequence is arithmetic or not, and then to write a rule for these sequences. First of all, this sequence is special because each term changes at a constant difference. What that means is when you begin at one term, you are either going to add or subtract a number to get to the next term, so it has a constant difference. For example, on this first sequence, when I start with the number 5, to move to the number 8, I'm going to add 3. And then from 8 to 11, I'm going to add 3. And from 11 to 14, I'm going to add 3. And from 14 to 17, I'm going to add 3. And if I wanted the next term in this sequence, I would add 3, and that would give me my next term, which would be 20. There is a constant difference between each of the terms. If you take a look at the next sequence, to get from 10 to 5, I'm going to subtract 5 or add a negative 5. From 5 to 0, I'm going to subtract 5 or add a negative 5. And so on for each of these terms. If we take a look at these over here, these are non-examples because I am not adding or subtracting a number to get to each term. In this case, I'm actually multiplying by 2 each time. And in this case, I have a pattern, but I am not having a constant difference. So these are non-examples. In order to be an arithmetic sequence, you have to have a constant difference between each of the terms. So what we are going to talk about today is how we can write a rule or formula that allows us to calculate any term in the sequence. So here is a rule that is describing a particular sequence, and it says that a to the n power, remember from before in our last lesson we said that that gives us the exact term that's in the sequence, 3 to the n, where n is the number of the term, plus 6. So if I want to find the first term in the sequence, what I need to do is I need to take 3, and the number of the term is given to me right here as my sub, so that's going to be my first term, and I'm going to add 6. 3 times 1 is 3, plus 6 would equal 9. So my first term, or a sub 1 in my sequence, is 9. If I want to find the 7th term in this particular sequence, I simply take my 3 times n, which is 7, the 7th term in the sequence, and then I add 6. So when I do my calculating, I take 3 times 7, which is 21, and I add 6, and I get 27. So my 7th term in the sequence is 27. Let's try one more example, a sub 20. So the 20th term in my sequence is what I'm looking for. So I'm going to take 3 times 20, because it's the 20th term, and add 6. 3 times 20 is 60, plus 6 would give me 66. So the 20th term in my sequence is the number 66. That is a rule or formula that allows me to calculate any term in the sequence. So I want to write the first 4 terms of the sequences that are given, which means I want a sub 1, a sub 2, a sub 3, and a sub 4. So to write the first term in the sequence, I'm going to take 3 times 1, which is 3, and I'm going to subtract 5. So 3 minus 5 would give me negative 2. That's the first term in my sequence. Now I want to find the second term. So I take 3 times 2, because it's the second term, which is 6, and subtract 5, and that gives me a 1. If I want to find the third term in the sequence, I take 3 times 3, because it's the third term in my sequence, which is 9, and 9 minus 5 is equal to 4. And then I want to find my fourth term in the sequence. So I take 3 times 4, because it's the fourth term, that's 12, 12 minus 5 is equal to 7. So these are the first 4 terms in my sequence: -2, 1, 4, and 7. In this particular example, I want to find my first term, so I'm going to take 1/2 times 1 to give me my first term plus 4. 1/2 times 1 is 1/2, plus 4 would give me 4.5. To do the second term in the sequence, I'm going to multiply 1/2 times 2 because the 2 represents it's the second term in the sequence, and then I'm going to add 4. Half of 2 is 1, and 1 plus 4 is 5. That's the second term in my sequence. I want to find my third term. So I have half of 3, which is my third term, plus 4. Half of 3 is 1.5, plus 4 would give me 5.5. And lastly, I want to find the fourth term in my sequence. So I'm going to take half of 4. Half of 4 is 2, plus 4, which gives me 6 as the fourth number in my sequence. So the first 4 terms of my sequence are going to be 4.5, 5, 5.5, and 6. Now what you can notice is that we calculated each one separately, and notice they are an arithmetic sequence because I have a common difference. Do you notice that in this first sequence I'm adding 3 each time to get to my next term? In this sequence I'm adding 1/2 each time to get to my next term. So let's take a look at how we actually can write a rule for these sequences. What we need to do to write this rule to find the particular term I'm talking about is we need to take the difference, d, times the number of the sequence plus a sub 0. A sub 0 is the term that actually occurs before the first term in my sequence. So d is your common difference, a is your first term, n is the number in the sequence that I'm looking for, and a sub 0 is the term before the first term. So here's what we want to do. First of all, when we have our sequence, we want to find out what the common difference is. What am I doing to get to the next term? And it looks like the pattern is I am adding 4 each time to get to my next term. So in this particular sequence, my d is positive 4. The other thing I need to be able to create my rule is I need to figure out what number occurred before my first term. Well, that's easy to do because I'm simply adding 4 each time to get to the next number. So if I want to go backwards, I'm going to subtract 4. So 3 is going to be my term called a sub 0, which means it's the term before my first term. So here's the rule that I'm going to write, and it's going to help me to make a rule in general for my sequence. So a sub n means I can find any term I want in my sequence. All I need to do is take the difference, which is 4, multiply it by n, which is the number of the term I'm looking for, and then I need to add 3, which is my previous term. Let's take a look at another example. What am I doing to get from one term to the next? Well, it looks like I have a common denominator already. What's happening in the numerators is I'm subtracting 4. So I'm actually subtracting 4 over 2 each time in order to keep my common denominator and subtract my numerators. So my common difference is going to be negative 4 over 2, or if I want to reduce that, it's actually negative 2. That's going to be my difference. Now what I want to do is figure out what term happened before my first term. So if I subtracted 4 over 2 to get to all my new terms, I'm going to do the opposite or inverse. I'm going to actually add 4 over 2. So if I add 4 over 2, that's going to give me 11 over 2. And this term is called a sub 0, and it's the term that occurs before the first term. So let's write the rule. A sub n, or the term in my sequence, equals the common difference, which happens to be negative 4 over 2, which we reduce to negative 2, times n, that's the number of the term, I don't know which one I want yet, plus my a sub 0, which is my term before my first term, which is going to be, in this case, 11 over 2. So let's see if we can write the rule for the nth term of the arithmetic sequence. So we have our difference, which is 4, and we have our first term, which is negative 6. So remember, what we needed to do was we needed to write our sequence as a to the n equals the difference times n plus the previous term, which is a sub 0. So if I'm going to add 4, because it's a positive 4 each time to get to my next number, I want to know what a sub 0 is, which means I need to back up a term. So instead of adding 4, I'm going to subtract 4. Negative 6 minus 4 would give me negative 10. That will help me to back up to get my a sub 0. Now another way that we can do that is this. We can say that a sub 1, which is negative 6, equals my difference, which is 4, times my n number, which is the first term, plus a sub 0. And we could actually write an equation and solve and find out what a sub 0 is. So negative 6 equals 4 plus a sub 0. And to solve, I'm going to subtract 4 from both sides. So negative 10 equals a sub 0. You can calculate to find the a sub 0, or you can simply use logic to say that if I add 4 each time to get the next numbers in my sequence, I can simply subtract 4 from my first term to back up 1 to get the negative 10. And you'll notice that we get the same answer. So now let's write the rule for our sequence. So we have a sub n, and that equals the difference. The difference is 4 times n, we don't know what that is, plus our a sub 0, which is going to be a negative 10. And that is the rule to find any term that we want in our sequence. Let's do another one. So we have d equals 2 and a sub 5 is equal to 9. Well, in this case, it might be hard to keep backing up until we get to the a sub 0 term, but it's not a problem. It can be done. We just have to keep subtracting 2 until we get to that point. Or we can write an equation to solve for a sub 0. So let's use this equation. We're going to plug 9 in for our a sub n, and that equals our difference, which is 2, times, and then remember our n, we're wanting the number 5, plus a sub 0. So we're going to figure out what it is this way. So 9 equals 10 plus a sub 0. So when I subtract 10 each time, I'm going to get negative 1 equals a sub 0. So I can solve an equation to find it. Or you could also say, if 9 is my fifth term, and I'm going to keep adding 2 each time to write my sequence, I could back up and subtract 2 each time. So 9 minus 2 is 7. Backing up again, 7 minus 2 is 5. Backing up again and subtracting 2, I get 3. Backing up again, I subtract 2, I get 1. And so if this is the 5, 4, 3, 2, I'm on the first term, I need to back up one more time to get my a sub 0, which is negative 1. So I can either solve by actually thinking about it and calculating it in my head, or I can solve an equation to get it. So now let's write the rule for the sequence. So we have a to the n equals the difference, which we know is 2, times n, the number of a term, and then plus our a sub 0, which is -1. And this is the rule that we could use to find any term we want to in this particular sequence. One more example. So we want to write the explicit rule. Here's what we do. Remember, we have a sub n is equal to the difference times the number of the term plus a sub 0. So we're going to plug in this information because we want to find the a sub 0 to begin with. So our a sub n, which is a sub 8, is equal to 16. That equals the difference, which is 20, times the number of the term we're talking about, and in this example it's 8. And that will help us to find the previous a sub 0 term. So we have 16 equals 160 plus a sub 0. So if I subtract 160 from each side, that equals -144 is equal to a sub 0. That's going to help us write our formula. Now again, could we get there in another way? Sure. I could start at 16 and keep subtracting 20 all the way back until I get to that a sub 0 term, which is going to be -144. So let's write the rule. The rule is a sub n, meaning any term I want in the sequence, is equal to the difference, which is 20, times the number of the term I'm looking for, plus my a sub 0 term, which is where I'm going to start, and that's at -144. This is the rule that will allow me to find any term in my sequence. Let's review. An arithmetic sequence has a constant difference, and the formula we need to use to write a rule for the arithmetic sequence is a sub n, which means the term I'm talking about is equal to the difference times the number of that term plus a sub 0. And remember, a sub 0 is the term previous to the first term. Please remember to complete the reflection.